Hi everyone. This is going to be a video that goes through some more examples on lesson 1.2, which is on recursive formulas. So first we're going to start off by using a formula to write out the sequence. So remember that this is our first term. u1 equals 7. That means that 7 is the first term in our sequence. So we can write down 7 as the very first number in our sequence. Then we want to know, okay, what are the next couple numbers in the sequence? And that's where our rule comes in. So un plus 1 equals 4 times un. This basically is saying that the next term is equal to 4 times the current term. So whatever term you're at, you multiply by 4 to get the next term. So if I'm at 7 and I want to get the next term, I'm going to do 4 times 7. So 4 times 7 is 28, right? Then to get the next term, I'm going to multiply by 4 again. So 4 times 28 is 112. Then 112 times 4 is 448. So we multiply by 4 again. And you would keep going. To get more and more terms in this sequence, you would just keep multiplying the previous term by 4. All right, so that's the first 4 terms of that sequence. Let's try another one. So again, u1 equals 12. That's telling us where the sequence starts. This is our first term. So our sequence starts at 12, and then we want to know what are some of the next terms, right? So now we need to interpret the rule. Here's our rule. un plus 1 equals un minus 6. So this is basically saying that the next equals the current minus 6, or basically we're subtracting by 6 to get to the next term. So if I'm at 12, to get to the next term, I'm going to do 12 minus 6. So that's 6. Then to get to the next term, I'm going to do 6 minus 6, which is 0. Then to get to the next term, we'll do 0 minus 6, so that's negative 6. And to keep going, you would keep subtracting 6. Subtract 6, subtract 6, subtract 6. And that's how you keep going out in your sequence. All right, we have one more. I need to scoot these down a little bit. All right, and this one's a little more complicated, but we know how to start. So we know that u1, that always tells us the first term of the sequence, right? So our sequence starts at 5, so we can write down 5. And then we want to know what are some of the other terms. So here's our rule. un plus 1 equals 3un minus 4. We need to basically interpret what that's telling us. So un plus 1, that's like the next term, equals 3 times un, which is the current term, and then we subtract 4. So this is telling us to get the next term, you need to do 2 things. You need to multiply by 3, and then you need to subtract 4. Okay, so to go from 5 to the next term, I'm first going to multiply by 3, so 3 times 5, and then I'm going to subtract 4. So 3 times 5 is 15, so we need 15 minus 4, which is 11. Okay, now we're going to repeat that process. So from the next term, we multiply by 3, so 3 times 11, and then we subtract 4. 3 times 11 is 33, so we need to do 33 minus 4, which ends up being 29. Okay, to get the next term, we repeat that process again, but this time with 29. So 3 times 29, and then subtract 4. 3 times 29 is 87. So we're going to do 87 minus 4, which is 83. And you could keep repeating that process to get more terms in the sequence. All right, so those are some examples of how you go from a recursive formula to the sequence. Again, you always are given the first term, so you know the first number in the sequence right away. That's what U1 is. And then you want to try to interpret this rule. So try to say the rule in words. UN plus 1, that means the next term. And then UN, that's the current term. So this is telling you, what do you do to the current term to get the next term? So look at those operations. We're multiplying it by 3. Then we're subtracting 4. Okay. Now we're going to practice going from a sequence to a formula. So we know that our recursive formulas always have two parts. We need U1, and then we need a rule for UN plus 1. The first term and a rule for the next. So U1, that's easy. We just find the first number in the sequence. So in this case, U1 is 0. For the rule, we need to figure out what is the pattern of this sequence. So look for arithmetic or geometric. 0 to minus 10, that's subtract 10. Minus 10 to minus 20 is also subtract 10. Minus 20 to minus 30 is also subtract 10. So this is basically saying that to get the next term, we take the current term and we subtract 10. So UN plus 1 is going to be UN, the current term, minus 10. All right, let's try that again with another one. So I know I need two parts, U1 and UN plus 1. U1 is just the first term, so I just read it off. What is the first number in the sequence? It's 15, so U1 is equal to 15. UN plus 1 is asking for a rule to get the next term. So we're looking for what is the pattern of this sequence. We might notice that 15 to 28 is plus 13. 28 to 41 is also plus 13. 41 to 54 is also plus 13. Okay, so we have the pattern. It's plus 13, right? So to get the next term, we would take the current term, and our symbol for the current term is UN, and then we will add 13 to it. So this is saying next equals current plus 13. All right, now we're going to do some geometric sequences. So again, we know we need the first term and the rule for the next. First term is easy, it's -2. Now we need to find the pattern. So -2 to 8, and then 8 to -32. So you might notice that there's multiplying by 4 going on here. 2 to 8 to 32, that's times 4 times 4. But then we have this flipping negative, and we can get that if we multiply by -4. So -2 times -4 is 8. 8 times -4 is -32. -32 times -4 gives us positive 128. So our pattern is times -4. Okay, so this means that our next term, UN plus 1, equals our current term times -4. You can write it just like that. You're taking the current and you're multiplying by -4. So we write UN times -4. Sometimes we write this as -4 times UN. Either is fine. All right. Last one. Okay, so we need our first term and we need our rule for the next term. First term is given to us, 6,561. And then we need to find our pattern, which will help us write the rule. So these numbers are not super familiar to me, but these ones, I see a pattern there. 81 to 9 is divided by 9. 9 to 1 is divided by 9. So let's check if that works for the others. 6561 divided by 9 is 729. And then 729 divided by 9 gives us 81. So our pattern is divide by 9, or remember, division is the same as multiplication by a fraction. So dividing by 9 is the same as multiplying by 1/9. So we can write our rule in a couple ways. We could say that to get the next term, you take the current term and you multiply it by 1/9. We could say that to get the next term, you do 1/9 times the current term. We could say that to get the next term, you take the current term and divide by 9, so use the division symbol. Or we could write it as a fraction. The next term is the current term over 9. These are all ways of writing the same thing. This is considering it as multiplication by a fraction, and this is considering it as a division. All right, so these are all okay. And those are some examples of writing a recursive formula from a sequence.